Your next challenge is entitled Block the Square in Tic-Tac-Toe. Create a function that returns a number which can block the player from reaching 3 in a row in a game of tic-tac-toe. The number given as an argument will correspond to a grid of tic-tac-toe. The top left is 0, the top right is 2, the bottom left is 6, and the bottom right is 8. So if you can envision that, it's numbering from left to right, from top to bottom, as we naturally would write. Create a function that takes two numbers a and b and returns another number. This number that you return should be the final one in a line to block the player from winning. So you can imagine this in a scenario where maybe you're controlling an AI opponent in a tic-tac-toe game and you're sort of scanning a board. You're looking out for opportunities for your opponent to win and you're trying to block those. So I like this. This is kind of like almost we're moving more toward useful problems and not just theoretical and made up examples. Anyway, you can see from the examples below this should help you understand the numbering system. Notice that 0, 3 returns 6 because if you can imagine the top row is 0, 1, 2 and then this 3 would start the middle row and 6 would start the bottom row. So that would be like a vertical line in the leftmost column, a win that way. If you have 0 and 4, that's going to be the upper left, 4 is going to be the middle square, and 8 is going to be the lower right, so that would be one of the diagonals. And then finally 3 would be middle row on the left, 5 would be middle row on the right, and then 4 you'd want to put a symbol right in the center to block that. The notes say that the values given will always have two filled squares in a line, so we don't have to worry about a situation where they're feeding two parameters that are no threat of making a tic-tac-toe. You could certainly check for that, and you would in a real scenario. I'll just accept their statement here as being true, but feel free to handle that if you like. It's always good to think about that and be aware of it, whether you address it or not. It's important to think along those lines that input isn't always perfect. Anyway, we'll go over to code. Please pause the video and give this an honest attempt. Come on back when you're ready. I would say that you could certainly do this in a way with a bunch of if-else statements. You know, if a equals 0 and b equals 3, return 6, and then else if a equals 3 and b equals 0, return 6, and you just get this huge series of if-else statements. That'll work in a simple case like tic-tac-toe, but even in tic-tac-toe it's pretty ugly and it gets long, right? But you can see how that's not really sustainable. It's not scalable. If your boss came to you and said, okay, tic-tac-toe is too boring, we got to change something, we're going to make a 5x5 grid, make it work. And then, you know, are you really going to write out an if-else statement with every possible case like that? That would be madness. So I'm not going to do something like that, even though it's probably the fastest way to do the problem here. I'm going to use this as an opportunity to get more into object-oriented programming, which is a very important concept. So you can see the program class they give us. That's kind of like our entry point, right? That's what they're going to call for checking our answer, this block player. So what I'm going to do is I'm going to make my own class, public class, and I'm going to call it Win Analyzer. And the idea of this class would be that it sort of holds the win patterns, and that will help us determine how to make blocks. It'll have all of the potential patterns that are winning, and then when we get input we can compare against those patterns. So that's the basic idea. Okay, so I'm going to make a constructor for this class so clients can use it. We will be the client in this case. Constructor has the public keyword, no return type, and is named after the class. And then this is sort of what you do when you initialize your object. Remember, classes are like blueprints for making your own custom types. We have the built-in types, booleans, integers, strings, etc. but you can compose more complex objects out of those basic types. And the class is the blueprint for doing that. It says how the data and the behaviors are organized. So I'm going to have, for my initialization, I'm going to end up having a class that says load wind patterns. Private static void load wind patterns. And this is going to initialize the object basically on the user's behalf. You know, I've seen people, I'm sorry, I didn't mean to put a semicolon there. Some people, I think it's terrible when they make the initialization happen after the constructor is called when it's not necessary to. That's a big mistake. If you can initialize and get your class as ready as possible at the point of creating the object, I strongly recommend doing that. Let's see, one thing. So we know that when we have this class finished, we're going to create an instance of it, right? We're going to have to do something. This isn't static now, we're making objects of wind analyzer type. You could do this as a static class. Without being a static class, we're going to have to instantiate an object of it. And maybe for tic-tac-toe that's overkill, but you could imagine in a more complex game, right? Consider something like a slot machine game where there could be different ways to win, right? You could have wins that happen because symbols fall on a pay line, or you could have a win happen because so many symbols appear on the board on the game window, even though they're not on lines. You know, it's like a scatter evaluation. And so you could have these different kinds of win analyzers, and you could either use them together to make all sorts of analysis possible, or you could swap them out at different times if you wanted, where what it meant to win could change during gameplay. That could be something interesting too. So I'm going to do it as a class here, not a static class. So because the point is to show more object-oriented programming. So I'll just call it win analyzer, and then to do this, we know you use the new keyword win analyzer. And look at my constructor took no parameters, right? So I can do it like this. And once this is called, I get an object of this class, and load wind patterns would have been called as part of this. So it'd be initialized with the patterns because I'm setting it up that way. And then basically we know we have to sort of serve this functionality. This is what they're looking for, how to block, right? So our class is going to do something like that, and we'll call it public int get block position. How about that? And it'll take, I'm going to call the little game boxes of a tic-tac-toe board cells. So I'll say int cell 1 and cell 2, just a couple game cells that it'll take. But this is the important thing, right? This is kind of the hook in here, right? Once we have our object, assuming I implement this right, I can do this. I can say return win analyzer, and to access an object's data or methods, you use the dot and then call the method name. I made it public so it is available. I wouldn't be able to call a private method here. And that's nice, you can control what's accessible outside of your class. And then I'll pass the parameters they gave me, which were A and B, right? These represent the cell numbers. And then it's that easy, right? So you could imagine this job of making this win analyzer class could be given to some other employee, right? And this could be my job. And then I write this and I'm done and I go to my next job. I just can count on this guy. We've defined this contract, right? I say, hey buddy, you got to give me this method. I'm counting on you for this. And then he or she makes a class that adheres to that, and I know I'm done at this point. I can do whatever I have to do, and it's their job to fill in the details. So that's kind of a handy way of doing things. So now let's make this work so when they call this, it does what it's supposed to. We should probably take care of this initialization first, this loading the wind patterns, right? So for that, I'm going to make a private member that's going to hold all the wind patterns. I always put my public stuff at the top, so people who want to use my class don't have to look through all the methods, you know, picking around. You got a couple public, couple private. I put it all at the top so anyone who wants to use the class can readily see what's available of it. And I always try to keep the public interface as small as possible. That keeps the object very simple to use. Imagine I had 15 public methods here, and you can see how the complexity goes up, where someone has to know maybe a little too much about your object to use it, and that's not good. That's overly complicated. Let's keep it simple. So yeah, this is it for my public interface. Just they can make objects of it, and this will get block position. In reality, a class like Win Analyzer would do a little bit more than this, but we're going to stay within the confines of this problem. So we'll get block position. Let's get our load patterns. I'm going to make a member variable for this. Private, no one else needs to know about it. Private, I'm going to make a list of integer arrays. These integer arrays are going to be size 3, and they're going to hold all of the wind patterns. And to that end, I'll call it wind patterns. It's a common pattern to precede member names that are private with underscores in lowercase letters, so I'm going to do that. I like that pattern. That helps people who view it while it's being used. They know right away that, hey, this is a member variable. This isn't some temporary thing I'm dealing with. And if you adhere to other advice about keeping your function sizes very small, that also helps, where you don't have to wonder, you know, because a function spans, you know, 100 lines, where you can't tell if someone defined it as a local variable 100 lines up, and you know you have to go looking around. So just adhere to all of the guidelines, and you'll be good. So we got wind patterns, right? We need to fill this thing up. So wind patterns, we know it's a list of integer arrays, and I'm going to initialize it with all the patterns here. And then for each element, we know it should be an array, new int, and I can start putting in all of the combinations, right? 0, 1, 2 would be one. That would be horizontal row in the top. And basically, oh, I'm sorry, I didn't mean to put a semicolon. We want commas separating each line. I'm doing this one on each line because it would go too far horizontally, so let's not go there. We know we're going to have a middle row, a bottom row, left column, middle column, right column, one diagonal, two diagonals, right? And then I'll just make these values correct. So you'd have 3, 4, 5 for the middle row. You'd have 6, 7, 8 for the bottom row. Now let's do the columns. 0, 3, 6, 1, 4, 7 for the middle column. And the right column would be 2, 5, 8. Diagonals would be 0, 4, 8, and 2, 4, 6. Hopefully that's clear. That's per the numbering system they gave us in the instructions. So this, yeah, we'll load up our member variable wind patterns and we'll be ready to rock there. That's good. Okay. So now we've got our wind patterns. We have all the possible wind patterns. We got to implement this get block position, and we're going to take advantage of these wind patterns to do it. So let's go for each integer array, we'll call it wind pattern, in underscore wind patterns. We're going to scan each one of those arrays that we just made, right? We're gonna look through all of them. And what we want to do with each one, imagine we grab the first one, we're going to say if wind pattern dot contains, do you remember contains? We've used that in the past, it's been a while. I'm going to have to bring in some using statements for this as well. win patterns contains cell 1, and it also contains cell 2, then we hit, right? We know we're dealing with the right win pattern. And the catch now is that we have to return the third value that doesn't match either of these two, the unique value in that collection. So, you know what? Let's make this a little bit simpler because I want to reinforce good concepts here. Let's do this. Private integer array get win pattern. Make everything really small, simple jobs, right? Oh shoot, I hit return, it's gonna run. Don't worry about that. So I'm gonna take this, put it in its own method, get win pattern. So at this point, if you have both, we'll just say return win pattern. And that'll be a nice little helper method. We'll stop there. We won't worry about getting the third value at this point. Let's break this out into really small, focused jobs. And if you didn't find either of those, you have a problem. We could throw an exception here or something like that. And, to get around it, I'll just do an empty integer array. So get win pattern. Okay, that'll be very helpful for us. This will get the win pattern corresponding to the two cells passed in, right? And also, let's not forget int cell 1, cell 2. There we go. So now, how can we use get win pattern in get block position? See, we made it even simpler now by breaking out into this helper method. You can say int win pattern equals get win pattern cell 1, cell 2. And then once we have that win pattern, let's use our link methods that we know for filtering, right? We'll filter out the two values given, and all that will be left is that third value that we want, right? So that would be perfect here. Do you remember the link method that does the filtering? Where, right? And we're going to give it that lambda. We know that each element in win pattern is an integer. I'm going to use n as a variable name for my integer. So we want where n is not equal to cell 1 and n is not equal to cell 2, right? The only one that's going to survive this filter is going to be that last value, that blocking value that we want. And at this point, from where we know we're dealing with an enumerable collection of integers, I'm going to go back to an array so I can access the first element. To array, and element 0 would be the first element. In practice, I'd probably check the size of this before accessing, but it'll blow up if we did something wrong. I think that's fine here. So we're going to have to bring in link for that. And also, you notice I used the list collection earlier too, so we should bring in system collections generic. Those hold a lot of those data structures that we've been using. And then using system link for that where method that we used. So let's look at this. We had our constructor that loaded up these win patterns. It fills our private member variable, which I'm also going to move here. I like to have my members before my methods, or at least have them grouped together. So load win patterns fills our win patterns up with all the potential ways to win. Good. Then we have this helper method, get a win pattern that corresponds to two cells that are on a line. And that looks through the collection of win patterns and returns it. This integer array size 3, all of them were size 3. Then get block position then can just find the win pattern corresponding to these two cells and filter out the known values to get the third one. And that's all this is doing. And I think that does the work. That should fill in the details needed to, adhere to this contract that we have with you can think of this program thing as the client, right? We're working for them. So we can try running this. Let's see what we get. Okay, we got an error on 41. An object's reference is required to access non-static member when patterns. What do we do here? Reference. Oh, static. Void. When patterns. So, okay, we could make when patterns static to get around that. Or that I don't know that load when patterns needs to be static. So, we'll remove the static nature there. Let's see if that works. Yeah, so I had this static method here, load when pattern. I decided not to make this a static class, right? We wanted to do with objects, so yeah, we get rid of the static, make everything object based. So yeah, I already kind of gave the overview of how this works. I think it should be clear now, but you can certainly hit me up with those questions. You might be saying this is overkill, but I really think this is the way to start thinking about doing these problems. You're just not going to survive doing things like I mentioned up front with these giant if-else statements trying to cover every permutation of values. So even if this felt like more work, I'd recommend going this way. It's going to save you in the long run. So we'll see you in the next challenge. Thanks.